First, thank you so much to the organizers of Responsible Tech Summit 2020 for having myself here to speak. It's a real privilege, especially amongst the rarefied air of the other distinguished panelists that we've had over the last few days. So thank you very much. Today, I'm going to be talking about AI targeted marketing systems, and in particular, thinking about the ethics and responsibility around them. My goal here is to kind of make a little bit more concrete some of the ideas that we've been hearing about over the last few days, and sort of provide by way of example some of the challenges and perhaps approaches to taking on responsibility and ethics in a system like this that's run by AI. So as Adina said, I'm the Chief Practitioner of Gradient Institute. My background is in machine learning research and practice. And I lead the practical application and training components of Gradient Institute's work. So a brief pointer to tomorrow, I'm also giving a workshop preview of a workshop that Gradient is delivering at the AgileAus conference later in the year. So if you're interested, that'll be on tomorrow at the same time as today. So just briefly, a little bit about Gradient Institute. We're an independent and not-for-profit research institute, and our goal is really to take on the practical challenges of making AI systems ethical. So part of that is doing research to develop new techniques. Part of that is training and implementation, helping organizations actually put those techniques into use. And part of it is trying to influence policy and regulation to improve the way these systems are governed. It's actually in December 2018, Gradient Institute's existence was announced by a joint press release from IAG, CSIRO's Data 61, and the University of Sydney. We started operating in July 2019, and so we're just coming up on our first birthday now. So we're very young, but we're coming out of the gate fast, I hope. Also, just to point out that a lot of the work that I'm talking about today, we speak about in a lot of detail in training courses that we run on some of the issues, particularly practical and technical issues around ethical AI. So we have some data science courses and also courses for leaders and other parts of the organization. Pardon me. Okay, so I'm not going to dwell on the impact of marketing in general and targeted marketing, because I think we've all heard, we all understand this in general and have heard some examples even over the last couple of days. But suffice to say that marketing and AI-driven marketing in particular is big business, and it has a big impact on our lives. So it's 618 billion roughly is the global advertising spend, bigger than the GDP of some countries. And companies like Google and Facebook have really made vast quantities of money off the idea of being able to target advertisements using AI. You can see that they're now some of the most valuable companies in the world. So this, and of course, we all understand how ubiquitous this technology is. It's in our phones, it's on our websites, it's when we get an email, it's often the tool behind it is some sort of AI system that's driving a marketing intervention. Now, apart from making a lot of money, targeted marketing and the use of AI in targeted marketing definitely has some unintended consequences, which are ethically dodgy, let's say. There's a few examples here, but I'll touch on one, which is just at the top left, where Facebook was charged for allegedly using targeted marketing in such a way that housing ads for more favorable areas were shown preferentially to white people in the United States compared to people of color. This is an example of a discriminatory harm that can entrench existing disadvantage and bad things in bad impacts from its behavior directly. But there's also more insidious harms and long-term harms associated with these kind of technologies. So we want to we want to understand how these systems go wrong and how we can address making them more ethical. So if we're building an AI system, and an AI marketing system in particular, how do we actually consider the risks? How does this system actually go wrong? This is a very complex question, of course, but we can think about it in two high-level ways. The first is that we, as the designers, fail to encode an ethical intent into the system. People think of AI as being, well, smart, it's in the name, intelligence, but in fact, these are very simple systems that do only what we specifically prescribe in terms of objectives. So if we leave out an important objective, like we don't want you to discriminate, then that system will happily ignore that objective. It has no baseline of moral sense. Everything we have to put in there manually. So one way these systems fail is by us failing to be explicit about our ethical intent. Even if we've defined an ethical intent and made it mathematically precise, which itself is a really difficult or maybe even impossible problem, then there's a huge challenge in actually designing the system so that its impacts actually align with that intent. And this is where all the challenges of statistical modeling and machine learning and automated systems come in to ensure that the thing that we want the system to do is actually what happens when we put it out in the world. So these are two ways of thinking about the big risks associated with these systems. And so mitigating them is really important. And there are lots of ways to think about processes for mitigation. And we've seen, the existence of many sort of AI ethics frameworks and processes along those lines. They share some common qualities, which are perhaps summarized here. So one is this need to quantify objectives. If we want a system to do something, if we want to prevent a particular outcome, or we care about a particular kind of harm, benefit, or discrimination, we must quantify that as either an objective or a constraint in the system explicitly. We then have to be very careful in designing the actions of the system, because ultimately we're building something that's going to change the world. And so we need to be very careful that we design actions so that those changes are in accordance with our objectives. We need to actually model that impact, model the relationship between our system's actions and the consequences in the world for our objectives. And then, critically, we will almost always find that we cannot have everything we want. There are fundamental impossibilities between our objectives that we have to balance carefully. And this is a fundamentally human problem that we have to solve. We have to balance the objectives very carefully and in a way that respects our views and our social license. Then finally, we have to realize that we're going to get the first 4 steps wrong, certainly. We have to test and we have to iterate. The idea here is not that we go through steps like this and end up with a system that is ethical. This is an incremental process that we'll have to go through again and again, and we're going to be making incremental improvements. Now, it's also worth pointing out that this is not a problem just for data scientists. Quantifying our objectives, understanding how to balance those objectives, having domain expertise to see what our system will actually do in the world, who are the vulnerable people that we might affect. These are problems that require a broad set of domain expertise. So we need leaders in our organization, people who are responsible for the system. We need domain experts who understand the consequences of the actions that we might take, and particularly for vulnerable people. We need to understand the interfaces of our system and how it's designed and what the implications of those things are for its impact. Then, of course, we have to perform often really difficult modeling jobs, and the data scientists and data engineers are a vital part of that. And then, of course, there's legal as well as ethical constraints for our system, so we have to be cognizant of those. And we mustn't forget that at the end of the day, it's not just about our system's profit or it's our internal KPIs. that involving the people who are affected by the system will help us catch blind spots, harms, or benefits that we didn't understand even existed. Gradient Institute is about to release some draft design handbook next week, which kind of goes into a bit more detail on some of these issues, and really trying to take a practical perspective about how you go from a sort of high level statement like be fair or don't do harm to actual code. What is that process of making it concrete? It's a starting point. We're going to license it under Creative Commons. We want people to give feedback and modify it. And really, we'd hope that it serves as a sort of starting point, perhaps for organizations that are looking to adopt policies or processes, or even just improve their internal technical approaches themselves and tailoring it to their needs. So keep an eye out. Keep an eye out for that. So the focus for the rest of this talk is really around direct marketing in the financial sector. So this is making it even more specific than targeted marketing. We're going to try and actually pull down to almost a particular use case and expose some of the issues. So the setup for direct marketing is in the context of AI is that we want to use a machine learning system to select customers or leads for a direct marketing intervention. So this might be to email them a discount, for example. It might be to ring them up and discuss their credit needs. But we have control over who we select, and we have designed an intervention to try and get the customer to acquire our product. Excuse me one sec. Now, this work is related to some ongoing work that Gradient Institute are doing as part of what's called the Veritas Consortium. So we're working here with the Monetary Authority of Singapore, who have a very laudable goal of trying to make AI systems more responsible in Singapore, in the Singapore financial industry. They've defined a set of principles for those systems, and Gradient Institute and its partners there are taking the lead in developing specific methodology and metrics to actually measure the alignment of these systems with the Singapore ethical principles that MAS have developed. So this is part of a part of a consortium of 25 organizations that are really trying to set the direction for practical AI ethics in Singapore. So this is really exciting work, and the work that I'm going to show you today is drawing on some of this ongoing work. So I've stated the overall way these systems work, but let's look at in a little more detail. If I'm a bank and I want to select customers to receive a marketing intervention, how do I actually do that with an AI system? At a very high level, what I rely on is having existing historical customer data that encodes the thing that I care about. In this case, it's probably something like whether the customer acquired the product or not. So based on historical customer data, I can train an AI model that predicts for my current customers whether they would be likely to acquire the product if I sent them the discount code, for example. Optionally, we can model whether they would respond if and only if we were treated. This is called uplift modeling, but in the simple case, we're just trying to predict their probability to buy the product. Once we have that probability, we typically sort the individuals from a low probability on the left to a high probability on the right, and we apply a decision threshold to say, well, everyone who's more probable than this line, we're going to send the email out to. And the choice of this decision threshold is one of the key sort of levers that we have to change the ethical valence of the system. So we're going to come back to that decision threshold in a minute. So let's make it concrete. Let's consider an example system, a hypothetical financial firm. The goal is to market personal loans to existing customers. So the intervention, the marketing team has come up with an intervention, which is an email offering a reduced interest rate. Now, this is a hypothetical example, and there may actually be governance and legal consequences relating to that intervention. But let's just follow this as an example. You might consider a sort of weaker intervention, which would just be to like ring the customer up and ask them if they would like to buy the product. So we've imagined in this hypothetical case, we've talked to those people responsible for the system and got some high level objectives, some high level things that we care about. And let's say they're generate a profit for the bank. We want to ensure that the any harms caused to the customers are reduced. We want to increase benefits to the customers as much as possible. And perhaps we want to ensure some notion of fair outcomes. So these are high level system objectives, but they don't by themselves tell us how to build the system at all. The first step we have to do is quantify these objectives. We have to measure the harms and benefits for the customers particularly. And ideally, we need to account for uncertainty while we're doing that. Now, this is itself a really difficult problem. And I think my good colleague Matt Beard has already mentioned a key point here that I want to reinforce from his talk, is that some of these harms and benefits are not immediately measurable. You have to go the right way around here. You have to first decide what are the important harms and benefits, what are the important objectives, and then find ways to measure them, rather than sort of starting with your available data and then just figure out which ones of those you care about. This is a vital step because, as I said, the system will completely ignore any consideration that you haven't explicitly encoded as an objective or constraint. And we will get this wrong the first n times. Is n even finite? Probably not, right? This is a really hard problem, but the way to tackle it is iteratively and with proper humility about uncertainty. You know, not only will we need to properly account for quantitative uncertainty, but we'll have to realize that that uncertainty itself is based on assumptions which are probably broken in some cases, and so we have to even think beyond the uncertainties that we calculate. So, with the system that we gave as the example, let's first look at the direct impacts of the system. So we can see this as being harms or benefits that are caused by the marketing intervention itself, separate from the product that's being marketed. And I've listed some typical direct consequences here. So let's go through them. First, a benefit from receiving the intervention. Well, in the example that we gave, you received a discounted interest rate if you got the intervention. And so you have, that is a concrete benefit that you have over someone that didn't receive the intervention. People often think of this sort of direct benefit as being really small and perhaps insignificant, but even small things like this, and an interest rate actually isn't that small, but even a discount coupon for a supermarket, over time can have insidious and long-term feedback effects if it's systematically done, that some people receive this benefit and others don't. We're all familiar with the notion of the annoyance at receiving an unsolicited offer. This is perhaps a small harm, but it's not zero, and we should recognize that ideally we don't want to be spamming people who have no interest in our product. So that's another direct consequence of the marketing system itself. So if those are the key harms and benefits for the customer, how do we actually measure them? And there's a whole spectrum of approaches here that kind of increase in complexity. We can start simple and look at something like what you might call the impact rate. So this would just count the occurrence of the harm or the rate at which the harm occurs per number of relevant people. So in this example, the rate would just be the number of selections. So for receiving a benefit, you can just directly count the rate at which you select from the cohort, and you can take a ratio there. So that we can measure directly, and we can do sort of Bayesian treatment of uncertainty on that ratio to come up with some uncertainty bounds. This makes a really strong assumption, which maybe is reasonable in this case, but in general isn't reasonable, which is that a harm for person A is always going to be the same as a harm for person B in the same situation. In other words, everyone is equally impacted by the same circumstances. This is in general not true. And so if we want to go do better than that, then we have to actually start trying to quantify the level of harm or benefit itself in a sort of loss function, if you will. That's this L down there in the equation, in the second equation. And then we consider like the rate at which harm occurs, either the mean harm, if we're sort of taking a utilitarian stance on sort of, or another way of collating the harms, like measuring the maximum harm. You know, we want to reduce the maximum harm that someone experiences from the system. Both defensible ethical positions, but different. So in either case, we can then, with the data that we have, if we have outcomes from the system, we can actually estimate these quantities. In the case of the benefit from receiving an intervention, it's just the selected customers. In the case of the harm from an unwanted intervention, it's the selected customers that did not acquire the product that we would compute these over. But that's not the end of the story. We are marketing a product here, and that product itself will have harms and benefits. Now, probably the central thesis of my talk today is the following statement: that if a marketing function causes someone to acquire a product, then it shares some responsibility for the product's consequences. This is a really key idea. Imagine a situation where I had a marketing system giving out loans, or marketing loans, and I look at the default rate of the loans given out by the marketing system or amongst the cohort of people interacted with the marketing system versus the people that walked in. If the default rate is twice as high in the marketing system as the people walking in, then it's reasonable for us to say that those defaults, those extra defaults, are in some sense the responsibility of the marketing function, not exactly the system itself, but the humans behind it that are responsible for it. So then we should look as well, when we're looking at a marketing system, at the indirect impacts. So these are harms and benefits caused by acquiring the product, but we can calculate that the marketing system caused the person to acquire that product in the first place. And it's worth emphasizing here that this is the primary point of why marketing systems exist, which is to cause people to take an action. So let's look at the typical indirect consequences then, for example, for our personal loan case. Benefit from acquiring the product. Well, presumably the person wants to acquire the product, they have credit available to spend, there is a benefit there. Harm from a rejected application. This is really important. If you ask someone to apply for a loan and they apply and then they get rejected, that rejection goes on a record in some cases, which may lower their credit score or even make it more difficult for them to access credit in the future. So there is a harm associated with a rejected application. And then, of course, there's the long-term outcome, the defaulting case, where we've provided a loan, but someone is unable to repay that loan. That is associated with a long-term harm. So to measure indirect impacts, we're asking a causal question here. We're asking, what are the impacts over and above a control, over and above the case where this system did not exist? And in order to do this, we actually need to create a control group. We need to have a similar statistically distributed set of people that are not interacted with by the marketing system, where we can examine their outcomes and compare them to the impacts of the people that were processed by the system. So then to measure these indirect impacts, we can define a differential impact rate, which would be the difference in the impact rates of the system and the control. So this is what establishes a causal effect on the harms and defaults that the marketing system is causing. In the case that we described, the impacted cohorts, again, as long as we have a control, we can measure these and provide a quantitative uncertainty based on the sample size. So in the benefit from acquiring a product, it's the selected customers that acquired the product. The harm from a rejected application, the cohort is the selected customers that had the application denied, and so on. So this at least gives us a starting point for quantifying the harms and benefits of the system that we described in our high-level objectives. We wanted to increase the benefits for the customer and reduce the harms. We also said we wanted to be fair. And one approach that's really concrete that we can take now that we've done this harm and benefit analysis is to measure fairness by considering the distribution of these harms and benefits between individuals and groups. This is a sort of process that we go through that starts with the harms and benefits and ends up with something that may actually look like a standard algorithmic fairness measure that we've heard about earlier in the week, or it might not. But the key idea here is that we're not motivating it from a sort of convenient mathematical formulation. We're motivating it from what are the actual impacts that we want to look at. And if we can see that systematically we're providing a benefit to one group at the cost of another, if that group is already advantaged in society in some way, then this is doing a real harm, and we can see that we're going to be entrenching this disadvantage. So to measure fairness, then we can just look at conditioning, for example, the impact rate, which I've shown here, conditioning on a protected attribute. So here A is the protected attribute. A1 might be men, A2 might be women. Then we can look at the rates, the impact rates, and how they differ between men and women. So for example, by looking at the ratio or difference of these quantities. And that gives us a concrete numerical fairness measure, but one that is informed fundamentally by harms and benefits. So we're at the stage now where we have some quantified objectives. Profit is reasonably easy to quantify. That one's not too tricky. We have got some direct and indirect harms and benefits, and we've got some notions of fairness. Our job is not done. We've provided some ways to measure these things. So we've got the measuring the impact part of the high-level process that I described. And we've got the intervention. The intervention was actually provided for us in the beginning. But what's missing here is how to know where these objectives should be balanced. All of these objectives are actually in conflict to some degree. Take the example for the left here. By changing our thresholds of who we select, we can maximize our profit. But if we do that, we will also see an increase in the harms due to rejections. Similarly, if we look at the rejection harm rate and compare and trade off between the product benefit rate, we also see that those two things vary together, and that if we want fewer rejection harms, we're also going to see fewer product benefits. And then even between types of fairness, we're going to have to make trade-offs. So if we consider the equity of the harm rate for gender and compare it to the equity harm rate for example, nationality between people who are citizens of the country of the bank and people who aren't, then we're going to have yet another trade-off. And just each of these dots represents a possible system. So in this case, we've got two dots, the green dot and the blue dot. And the key idea here is that selecting between these systems is a question of human judgment. There's no equation that will tell us what the right answer here is. This is about how we value those things. How does the magnitude of this kind of harm compare to this other kind of benefit? These are really hard questions, and ones that we've been struggling with, and that the ethicists and moral philosophers have been struggling with for a very, very long time. But another way of looking at it is that these are the fundamental questions that we ask every day of systems that impact the world. We're always trading off different objectives of our systems, be it how easy they are to use, how much profit they make, how much the long-term benefits outweigh the short-term benefits. So by making these harms and benefits as quantitative, we're able to actually encode our preferences directly into the system and say, this is what the trade-off that we want you to make is. If we don't do that, the system is still going to make a trade-off. We just don't know what that trade-off is. It will sit somewhere on this line, and we will have neither the knowledge or the ability to justify that choice if we don't go through this process explicitly. So even once we've balanced the objectives, it's just really important to reiterate that this process is itself fraught with errors and uncertainty. When we actually deploy the system, there will be unintended consequences. There will be things that we haven't thought of. That means we have to be very careful about how we test and scale the system. Presuming it works and then immediately rolling it out to 16 million people, definitely not a good idea, and one that I think we've seen a few examples of, unfortunately, in Australia. Uncertainty is one of the key ideas that we have to embrace if we're going to go through this process, and estimating uncertainty is a critical part of this process. I emphasize this because in many cases, the standard machine learning sort of toolkit does not emphasize uncertainty nearly enough and provides best guesses, which are enough when you're existing in, is this image a dog or a cat, but are not enough when you're making consequential decisions about people's lives. Those uncertainties themselves will be wrong. And so we have to continually rely on domain expertise to test the assumptions that we're making, to test the bridge that we've made between the high-level concept of being fair and the particular set of numerical measures that we've created. And of course, what we've done here is just identify some really obvious direct impacts of this system. There are going to be insidious long-term impacts, and there are going to be feedback effects. When we give someone credit, it makes it easier for them to get credit in the future. When we deny someone credit, we make it harder for them to get some credit in the future. And these feedback loops over the long term have the potential to really damage our society. So there is no golden solution here, but I at least propose as a starting point that you engage as many cross-disciplinary people as you can. You listen to the people that might be affected by the system, and you go through some sort of iterative process along the lines that is outlined here. So that's my time. Thanks very much. I think we've got some time for questions now, so I'm really keen to hear your questions and happy to answer them.
Lachlan, that was fantastic, but a little bit scary, I must confess. I just wondered if anyone has got questions, please throw them in now. I just wanted to go back to, you said you've been working at Gradient on this process from the Be Fair to the code, and you're releasing that, I think you said next week. Can you just explain that? Is that going to be useful for people potentially on the line to manage this?
I certainly hope it's a starting point. I mean, we're very, very far from here's the line of code that you should write. This is a whole field, right? I mean, the process that we embark on in the world of ethical AI and in the world of ethical machine learning is exactly this process of bridging the gap between ethical concepts and lines of code, right? So we haven't solved it, but I do hope it will be useful. It provides it at least encapsulates the years of thinking that we've done and a lot of the experiences that we've had building consequential systems. And yeah, I think you should see it as a starting point, but most people are at the starting point, right? These are new technologies, and there's very little off the shelf that can be done. Each of these problems, I think, as you see, requires careful analysis of the particulars of that problem. And so what we've tried to do is provide a guide for that process. And yeah, so yeah, we'll probably post the link up on our Twitter or Facebook.
And yes, and look, we'll share it too. Look, Fred Chilton, thank you, Fred, has made a bit of a statement here, which I'd like your comments on. He's said that the decisions on trade-offs will always reflect the personal values of the decision-making individual. Now, again, we've had discussion about this during the week. Would you like to give your input on that?
Well, I mean, I would take perhaps a different view there, although maybe I'm misinterpreting the point. We have built the mechanisms of responsibility and governance and decision-making in government, in a corporation, in any large sort of organization, is precisely designed to make trade-off decisions, right? We're always having to weigh the needs of people A with the needs of people B. When we set the budget in government, we're doing this, right? It is a possibility that an individual in an organization just sets those trade-offs. But that would be a really bad failure of governance of an AI system if that were the case, right? The key thing here is to engage existing risk and responsibility governance and decision-making structures with these systems. The danger, right, and what we don't say you should do is that the well-meaning data scientist makes this trade-off using their own judgment. These trade-offs need to be exposed to the people who are responsible for them, and those decisions need to be made with the same accountability and rigor that they would be made about a non-AI system.
Just wrapping up, I had another, I just wondered, seeing you're working in this space and sort of sharing such a scary scenario really of what's happening either in banks here or in Singapore, as you mentioned. I mean, are you feeling optimistic that people are taking this seriously and building these sort of fairness in and evaluating things properly, or do you think we've still got a lot of things to be worried about? How optimistic are you about how organisations and governments are approaching this?
I can't speak for every country, but I'm certainly optimistic about Australia and I'm optimistic about Singapore, and those are the two countries that I've had some exposure to this problem on. I mean, Australia has, of course, its AI ethics principles, but there is a clear need, want and desire that we've seen to move those principles to the next level of actually, okay, let's implement them. Let's see what this looks like in a concrete way. And the key thing here, right, is that this is about incremental improvement. These systems do exist already. We can, by engaging in this process, we can start improving their ethical valence, improving how they impact customers as well as the bank. And it's just worth pointing out that while it is a bit scary, that's often because it forces us to think about explicit trade-offs that we don't like acknowledging, despite the fact that they do actually exist, right? And that's a very human thing to say. Well, of course, I want both. I want it to be perfectly fair for everyone, and I want it to be perfectly no harms, please, at all. Well, we can't have that, but it's better that we acknowledge that and try and make the best judgment that we can than sort of put our head in the sand.
I think that's a great note to finish the session. I want to thank you so much, Lachlan. It's been really illuminating. We actually were hoping we were going to get a bank this week to actually share their journey from their side, because as you say, there's a lot of work being done. So hopefully if we run Responsible Tech next year, we'll be having more of these case studies, and would love another one from you. And I know we've got a workshop from you tomorrow, so looking forward to that and hearing from you again at AgileAus in October. I want to thank you and Tabiro and Bill and the whole team at Gradient. It's just wonderful what you're all doing, and we're so excited to see the next things coming out of Gradient. So thank you very much. Please join with me in thanking Lachlan. We'll be back at 12:15 with Second Peter. Thanks so much, Lachlan.
Thanks, everyone. Thank you, Rachel.